This is the additional sheet that I just put on there today, and it is S3.2, and that's going to be your sheet number down here, S3.2. So just remember that, and go ahead and, of course, label it as such. You can tell that by the details. This is detail 10 on S3.2. First thing to note is these two right here, 9 and 10. We will not do those, so do not draw these two. They're not referenced on the sheet, and so I'm not going to bother you with them. Excuse me. But we are going to draw the others, and I just want to talk about those for just a minute. What we're going to end up doing is doing all these details. In chapters 6 and 7 in the book, you're also going to be doing those as part of this whole final assignment, going through chapter 6 and 7, and I'll try to put something up on that if I need to. But what's going to happen is some of this is going to be like detail 1, for instance, S3.2, detail 1 right here. It is referencing a steel connection, which is something that we're going to look at. We already talked about it in construction materials in the past, but chapter 6 and 7 of the book get in more detail. And so what we're doing is drawing the steel column, tube steel column right here. But it says, see column schedule. So what we're doing is we're drawing a general detail, and then we're saying, you need to see the column schedule to see which column is actually going to be used in which location. And then up here, it's saying, or talking about the different W sizes, W12, W14. So what that means is that this beam right here could be a W12 or W14, depending on where it's used. But if we're using a 12, we're using 3 bolts in these plates, 14, 3 bolts in these plates. And so the plates being are right here where the bolts are connecting those two together. So, it depends on what we're doing. It says see plan elevations for exact sizes and top of steel. Anytime you see TOS, that's top of steel. So where is the top of the steel located? In other words, what's the dimension to the top of the steel right here? We won't know unless we see the plans and elevations. And so that's, kind of how that's going to work. But this is just a general detail, and a lot of times in structural you'll see that it'll be a general detail showing the connection with some notes saying, look, this is basically how it's going to work, but depending on what type of steel, or what size steel rather, and the exact dimensions or this or that, there may be some variables, but it's going to give you the basic connection. That's what that's doing. Over here on number 2, same type of thing. It's a little more exact. It's a wood beam to wood column connection. So here we have a 4x4 wood column, 2 2x12s, 2 2x12s coming at me that we're cutting through, and then we have this particular type of Simpson or steel connector. This little item right here is this Simpson ECC LL3 connector, and so what it does is they help connect, and you can see it from a plan view up top. All this is that Simpson connection device, the different devices we use to connect these beams to the columns. And so if you go to Simpson Strong Tie website and look up this type, it'll show you what those connectors look like. And so then you can actually get sizes for these things. That's generally what's going to happen. You can actually go to Simpson's website, look up this, and they'll have CAD drawings, and you can bring in that exact connector, put it on there, and use it. And then what it has is a couple of bolts running through the 2x12s, and it's obviously that's how the bolts are what secures the wood beams to the connectors, and then the connectors connect the beams to the columns. So I would suggest going to the Simpson website, looking up these connectors, and you can find out exactly what they look like, and even get CAD drawings to pop in here. Now the bolts, those are going to be specified in the specifications, so you're probably not going to have an exact size for those, so just make them look similar to what's on here. They're not called out on here because again, there's in the specifications. So, you know, just make it look pretty good, make it look right, and then just know that generally those are going to be called out in the specs. But you can go to that website and download those connectors. Over here, we have what we call a moment resisting beam, which was touched on in chapter 5 a little bit. But it does give you some specifics: W12 by 22 beam, what size plate, what kind of cap plate is on here. You know, all this different information. And then what's happening is on top of this steel, there's a couple of 2x bolted through it, because what's happening is we've got steel that we're using to support part of the structure, but then the actual trusses, if you remember from the sections, they're made out of wood. So what has to happen is we have to have some treated wood bolted to the steel, so that then this other wood can then just sit right down on top of it, and we have a wood on wood connection. Because remember, anytime wood's in contact with something other than wood, it's got to be treated. So these, whoops, I just moved my arrow. So these two would be treated, or at least the bottom one, but should be both of them, bolted to the steel, and then this normal wood truss is then put on top. And then it gives us some elevations, truss bearing height here, truss bearing height there, depending on which one we're looking at. And then a lot of notes. And just know that this is a weld note. That's a fillet weld. Okay. That means it's a fillet weld. It's 1/4 inch in size and it's 8 inches long. That's what these different symbols are talking about. I think we had another one over here. Yeah. It's a fillet, 1/4 inch in size. It says 1 inch less than the length of the plate. So in other words, the plate varies up here. So it's going to be a 1 inch less than the length of the plate. So we're stopping an inch short, and it's typical. Okay, and it's a field weld, which means it's done on site. But this again is a pretty typical type detail where we're showing the W beam, or W column rather, with the W beam. I'm sorry, I'm totally misspeaking. This is a tube steel column with a W beam. One thing we don't have is we don't have a size for this one shown. Okay, that one, since this is a what they're calling kind of a typical detail, moment resisting beam connection at that arrival hood. I'm trying to look real quick and see if they even give us that in the sheets that we have. No, it's not even referenced on this particular sheet. And so what we're going to do is we're going to assume some things, and we're going to assume that this beam right here is going to be the same size as this other one, because they look basically the same and they should have been drawn correctly. So we're going to assume that this right here is also a W, that's horrible, that is a going to be a W12 by 22 as well. So we'll make this one a W12 by 22. Okay, so we will do that as well. And some of these aren't referenced on the drawings, but I'm going to want y'all to draw them anyway, because it's a good detail and it kind of shows you how everything goes together. And some things are not referenced on here again, like these. It doesn't give you a size. It doesn't tell you what size those are on this particular detail, because those are specified elsewhere. But I will tell you that these two plates right here, let me just use what I already have, this arrow coming down. These are 2x6s. So these are two 2x6s. 2x6 top plates. Okay. And that's what those are. And you'll find when you bounce around from company to company and drawings to drawings that there are some things that are referenced or detailed and noted out on every detail. Some things are not. Some things, you know, if they've got this noted somewhere else, that, you know, in general, all wood in contact with steel are, you know, 2x6 treated, they won't note it on here. It's just a way of preventing duplication. Sometimes people decide to detail and note everything along the way, so it just kind of depends on the person and on the company. This is just typical overhang detail. Not a lot to it. It's just a very typical overhang. There's some things that we don't have sizes, but this is just typical brick. We don't really know what size all these are, what size trim this is, all that, because that's on the architectural drawings. So again, just kind of make it look pretty good. We're mainly worried about the structural notes, which is what type of sheathing we're using, what type of trusses, what type of clips, what type of, since this is a load bearing wall, what type of stud it is, what size is it, what's the distance. The finished materials we're not worried with. That's an architectural item. Right over here, what we have is a detail on the arrival hood. And you can kind of tell what's going on. Tube steel column is coming up. We have this cap plate. In other words, it's a plate right on top of that tube steel column. It's welded onto it so that this beam right here, this W22 or 12 by 22, can sit on top of that and be bolted to it. So these bolts are bolted this beam to that cap plate right there, and it's running all the way through. This beam, this 12 by 24, is actually coming straight at you. We're cutting a section through it, and it's just dying into this 12 by 22. It's running into it, and there's a plate coming off of the 12 by 22 coming straight back at you, so you can't really see it, but it's there. And so there's a plate coming straight out, and then it's bolted to this W12 by 24 that's coming straight at you. So the 12 by 24 dies into the 12 by 22, and it's attached to it with this plate and 3 bolts. So that's kind of what's happening right there. And then the again, we have the cap plate. It's 12 inches by 6 inches. Okay, so it's, since this is a 6 by 6 tube steel column, we can make some assumptions. It's going to be 12 inches. That was a horrible line. It's going to be 12 inches this direction. Okay, so it's 12 inches wide, 6 inches deep, which is front to back the way we're looking at it, and then it's a 1/2 inch thick. Okay, and then on top of this beam, just like this previous detail that we looked at over here, on top of the steel beam, we have 2 2x6s running straight on top of it, and that's what we're showing here. Double 2x6 top plates bolted to and running right on top of this steel beam, and then in the background 2 2x6 top plates right there running on top of the steel beam all the way down with bolts through it every so often to hold it. Okay, and again, that's something that would be in the specs. If it's not noted right here, we don't have the specs, so we'll have to assume it's in there. What we're doing is just kind of putting them at an even interval. It looks like right in between each truss. So here's a cord to the truss, cord to the truss, so just kind of put them in the middle. Okay, and then these are the hurricane clips, and they don't specify what type, so we can just kind of, you know, create this little rectangle and put a little L-shaped polyline or something right here to show something is there, and then label it as a hurricane clip. And then of course we just have our other notes. Again, we're not doing those two. Typical roof, this is a combination of everything we've looked at so far. So we've got steel column, beams running into each other, double wood top plates, truss on top. We know an overhang. We don't know a lot about the details, so it's just kind of single lined in almost to say, hey, there's a lot of detail going on here. See the architectural plans. Top of steel elevation. Excuse me. So 9'9". Excuse me. Above finished floor will be where the top of that steel beam is, and then the actual truss bearing. So the difference between the top of the steel and where the truss is hitting right here is 3 inches, which is the difference between the double top plates. 1.5 inches is 3 inches. So 9'9" plus 3 would be 10 above finished floor for the truss. But this is basically just a a combination of the other things we looked for. And you can see this is a moment resisting connection, which is what was detailed out right up here, moment resisting beam connection. This roof section, this is actually happening in the one of the building sections, as this is called out, and this gives you a little more detail as to how it's connected. 2x12 floor truss, or joist, I'm sorry. This is where the truss comes over and hits it. You got joist hangers right here, so it shows a lot more detail about how it's put together. And it's fairly simple to understand. Again, a lot of these, like where this comes up, what angle, these are just estimated on here. The actual shop drawings for the trusses would give us real dimensions. And then down here is the roof section, or the detail for the little porch, which is pulled right off of the other section. But you can see this connection right here is the very, I guess that'd be the very first one, second one, I'm sorry, that we did right here. So that's what's going on, 4x4 wood column, 2x12 beams. That's where this occurs. So again, you can see there's a lot of different details going on in there, but chapter 6 and 7, again, you will be doing at the same time. They're going to talk a little bit more about the steel connections and how that works. And you can see some of this is left up to the architectural drawings. Some of it's left in the specs, and so it may or may not be noted on the actual drawings. That's going to vary depending on who you're working for and what they want you to do. But this is a pretty good general overview of some basic details. And if you have any questions, anything like that, again, please email me, post something on the discussion board. That'd be the preferred way. Just let me know one way or another, and we'll take care of it.